Hello, everybody. Thank you so much for joining us for today's first virtual LJC event of 2023. We're really pleased to see you all. So yeah, thank you for joining us. And we are going to be hearing from Liam today. We're really excited to hear what he's got to bring us. Let me introduce myself for those of you who don't know me. My name is Abby. I work with the LJC and the other 15 plus communities, all of which are free and run by RecWorks. We are a tech recruitment company with a massive difference. So obviously, as a recruitment company, we are always on the lookout for more clients, and some of our best clients have actually come from community members who recommended RecWorks to their talent team. So if you're hiring for a new team or you're working for a company that is, please do let us know, and we'd love to see what we can do to work with you. If you want to know more about what we can offer, just ping me a message on Twitter, LinkedIn or Slack. My name is as you see it on the screen, and we can take it from there. So I mentioned a difference. What's the difference? I can hear you asking. Well, also, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. If people want to learn and others want to teach or share their knowledge, we are more than happy to connect you through our communities and events like this one today. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run hundreds of different events for engineers and developers, students, graduates, CTOs. We have run conferences, lightning talks, hackathons, all sorts. Earlier this year, well, last year now, because we're in 2023, we made our 4,000th introduction through our Meet a Mentor community. That's another one of our free communities. We're so excited to have reached that milestone, and we're really looking forward to making our 5,000th introduction through that community as well. As I've already said, we love to give opportunities for people to connect, and this event is part of that goal. If you want to know more about any of our communities, please do get in touch with myself, Helen Lewis, if you know her, or Barry himself, if you know him, and we can take it from there and introduce you to the right people for that community. The recording of today's session will be available for you on YouTube. I will put the link in the chat for you as we go through. If you have any questions as Liam is talking, he's more than happy, he says, for it to be an interactive session. So please do feel free to unmute and ask a question, or you can put it in the chat if you're not able to unmute. That's absolutely fine. And we'll be monitoring that as we go through, and we can get some discussion going during the event as well. With no further ado, though, let me hand over to Liam. Thank you. Over to you.
Terrific. Thank you. Let me get the slides up. Okay. Thanks again, Abby. Hopefully all my Zoom controls are out of the way. And yeah, great to be speaking with the Java community this afternoon. As Abby said, happy for this to be as interactive as possible. So with that in mind, I want to just see if everyone's chat is working on the Zoom, and I'll kick this off with a question. If anyone recognizes this logo, please do type it in the chat. You will need to be either an internet historian or as old as I am to have encountered it. I don't see anything in the chat, so I'm going to assume this is a young crowd. Usually somebody guesses Netscape. It's not Netscape, but it is in the right ballpark. This is the browser for the logo, sorry, for the Mosaic web browser, circa 1994. Wasn't the first web browser that I used, but I certainly spent a lot of time with this one back when I was, well, writing my first web applications. But anyway, this browser, and the reason I mentioned it, comes from a time before search engines, before Google and before lots of things, and at a time when if you wanted to know what was happening on the internet or what was new on the internet, you'd kind of go to your browser's homepage, and this is the same homepage. You can still get it on the Web Archive. Looks like this version was pulled from sometime in 1996. but the interesting thing here is your browser gave you your homepage, and down here we've got some resources to introduce you to cyberspace and keep track of its growth. Most interesting is that if you wanted to know what was new on the internet, well, there were humans that would keep track of what was new on the internet, because it might not change from one day to the next. And that's quite a lot different to the internet minutes we have today, where we might have 2 million Tinder swipes or 500 hours of YouTube content every minute. Back in, well, certainly back in 1994, there might be a handful of new websites each day, but that was about it. And if we look at the 1st of May, 1994, my shameless claim to fame is that I built my first, actually my second web application. So I've been doing this quite a long time. My name is Crilly. I'm project lead for NGINX Unit. That's what I'm going to be talking about today, and a little bit of NGINX as well. And when I'm not doing that, I'm doing the thing on the right. So let's get into it. And I think many of you might be here because this is a talk about NGINX. If you're using NGINX or have experience with it, I'd really like to know, or if it's or if you're just curious, please give me an indication in the chat, and I'll know how deep to go on this particular part before I get into the technical detail. I'm waiting for chat messages, so yeah, can I get a how many years I've been using NGINX in the chat? That would be really good. So while I'm waiting to hear what people experienced people have of NGINX, thanks, Craig. Cool. It gives me helps me understand where to position these next few slides. So if you haven't heard of NGINX, you've probably heard of Apache. These are the two primary web servers on the internet, and NGINX is not as old as Apache, but not that far behind. But still, this quote comes from when the original founder of NGINX, Igor Sysoyev, was around the turn of the century. So that's kind of how long we're talking about. He was running a bunch of Apache web servers for a large Russian internet giant, so the equivalent of even before Yahoo, around that kind of time, the Russian equivalent, you would say. And it just wasn't coping with the scale. So the internet was going through really explosive growth, and some of the architectural limitations of Apache were struggling to help it scale. That's the problem that Igor set out to solve when he first designed and implemented NGINX, and latterly, probably in 2004, open sourced it. And the analogy that I like best about what it's like to be a web server or to build a web server is that it's a lot like playing a game of chess. You've got the rules of the game, the HTTP protocol, you've got clients as an opponent, and they come along and they make a move, like they ask for a web page, and then the server has to interpret that and then provide a response. And they might ask for another move, might arrive immediately afterwards. There might be some delay. The client might have got everything he wants from you, but there's no indication that they're done, and so you're kind of hanging around waiting to see if there's another move coming. And if you're deploying this web server as a reverse proxy, then actually you're playing chess on behalf of someone else, and the backend server, you have to relay the moves to it. And usually the backend server is not quite as adept at playing chess as you are. Ultimately, most of the time spent playing chess or being a web server is waiting. And it's this waiting that causes problems. Now, you're holding up memory, you're holding ports open, lots of things like that. You're potentially consuming an awful lot of resources waiting for a move to arrive, or a bit of network to be read, or a file to be pulled off the disk. And so how web servers used to play chess, and sort of the first implementations, I'm talking even before Apache, but certainly the early versions of Apache were like this. You'd have the protocol spec, the board, the rules of the game, the chess pieces, and for each new HTTP request that came along, you would create, you'd fork a copy of yourself, that program, and handle the request in the context of that program. And when you were finished, you could clean them up again. Works really well. It's quite fast, but it doesn't scale because all these copies of the same program mean that you end up consuming an awful lot of resources, and especially when most of your time is spent waiting, that's a really inefficient thing to do. So what Igor's approach was, and how NGINX plays chess, is that there's just one program. We don't have multiple copies of ourselves. We have the same rules of the game and the chess pieces and the understanding of the protocols. But what happens is that every time a new client turns up and makes a request for a resource or a web page or a proxied resource, we essentially just pull some memory, make a playing space available, and so there's a chessboard essentially provided for each client, and then we wait until something happens, and we go around an event loop, an asynchronous event loop, waiting for events like there's some more network from the disk, or some more data read from the network, there's some more data read from the disk, the client's made another request for an image or a style sheet. And then we take care of that event as it happens, and we go around the loop waiting for things to happen. It's a lot like a grandmaster playing an exhibition tournament of chess. Goes around the room, and if one of the opponents has made a move, he immediately responds to that and carries on his way around the room. And this helped NGINX scale way beyond what was available, or was possible at the time. It solved the challenge that was known as the C10K problem, or how to handle 10,000 concurrent requests on a single server. And it blew through that on modern hardware. We had hundreds of thousands of requests on a single server. And the other advantage that it has is that these what are known as worker processes that handle the client requests, we can have more than one, and we can pin them to CPU cores. And this is what really helps NGINX scale almost linearly with CPUs, and it's what has enabled people like Netflix to deliver upwards of 80, 100 gigabits per second on a single piece of hardware. So these were some of the innovations that NGINX brought to the web server and the reverse proxy landscape. The asynchronous event loop, so that we were more efficient, could do more with less resources. The multi-process architecture, so it's not multi-threaded, it's not forking. We have a master process that handles configuration, worker processes that handle the clients, and that means they scale really well with CPUs. And the third thing that was notable is that changes to the configuration were seamless to in-flight requests. So basically a new set of worker processes get spun up with a new configuration. The old worker processes finish handling whatever they were doing and then gracefully shut themselves down, and there's no impact. And you can make configuration changes very frequently without any interruption to clients. So there were some of the changes that NGINX brought to the web server landscape. And the result of that is, I think 2004 was when the very first open source release 0.1 was released. As you can see on the green line, the first arrow pointing at T is that open source release. The second arrow pointing at Z is the 1.0 release, when it was declared sort of fully stable, and from that point onwards, the growth and adoption of NGINX as a web server reverse proxy really took off until it overtook Apache around in 2019, and remains roughly in this position with, I think, about 33–35% market share today. That's the NGINX story, but I realized that or I expect I'm talking to a bunch of Java developers, and I want to get into the context of web applications, and particularly the web application stack with Java. So the interesting thing about that timeline is that it's the massive growth and adoption of and success of NGINX was around about the same time as the LAMP stack came into play, where we had Linux, Apache, MySQL, the data store, and PHP that really democratized web development, sort of essentially enabled sort of the Web 2.0 movement, and provided this open source stack of loosely coupled projects, but in a way that was well understood, well documented, and really well supported by the community, to allow people to build with confidence really large scale web applications. And that stack has evolved over the last decade or so, whereby we have a web server, a reverse proxy of some sort at the front end, handling these sort of internet facing traffic, then a code on a web framework, notably now very highly abstracted from the underlying data store, which might be, again, MySQL, MariaDB, or it might be something enterprisey, or it might be NoSQL, or some other modern distributed data store. It doesn't, the developers are a lot more distant from that than they were when you were interacting directly with MySQL. And then we just need a platform with a kernel to write it all on. And we care less and less about what's going on the lower we go down the diagram here. And at the front end of all this is some load balancer or CDN or other network device, which is bringing our traffic in. It might otherwise be an ingress controller if you're thinking about this in the context of a Kubernetes environment. And what's notable is that really the bit that software engineers and developers are concerned with is that HTTP interface into the application, but mostly the code, the framework. Everything else is often either outside of control or just less interesting. And so it's in the context of this evolving web application landscape that I wanted to look at where NGINX is looking for the future. Because the code and the framework have seen massive evolution and innovation over the last 10, 15 years. But no one's really paid that much attention to the web server thing. Partly it's not broken. The standards, although we've got HTTP 2 and pretty much HTTP 3 now, most of what happens at the application runtime is HTTP 1, and that hasn't really changed. So, which is incredible. But also it means that the underlying technologies that serve that traffic also haven't changed very much. And what this means for NGINX is that bizarrely we're almost trying with this new project NGINX Unit that I'm about to introduce. We're looking at moving away from the service proxy model. Now, the reverse proxy model is great, but actually most of what we need is high performance load balancing, so that we deliver high availability and routing to web services. But what we actually need from the reverse proxy is not a lot. We need SNI routing and HTTP caching. The middleware part, all those extra things that get added into reverse proxies to have applications run, works well when you have a highly centralized environment. But the more you have distributed applications, the more you have microservices, the less sense it makes to start splitting the behavior of my application in multiple different places. So we really want the application to behavior to be defined at the runtime, and let the network functions get traffic there efficiently and effectively. And some of this is how NGINX Unit was born. So NGINX Unit is a new project. It's on a completely separate code base to the NGINX I've been talking about. and it tries to solve some different problems. The idea for Unit happened about halfway along the NGINX timeline, around about 2014-15. Igor had been experimenting with NGINX version 2, which isn't a thing, by the way, just some experiments. And then around later that year, 2015, there was a project got spun up to try and deliver web applications without a separate app server. So initially PHP, building on that LAMP stack, Python, Ruby, and then sort of some of the ideas then combined into this new project called Unit. It's been available under open source license 2017, so it's going to be sort of really 5 years old, and we've been stable since 2018 with the version 1 release. But we call it the Universal Web App Server, with a nice robot logo with 3 arms, because we do 3 things. So NGINX Unit is a web server. It can serve static assets, resources, style sheets, all that sort of stuff. It can run the application code natively without any additional moving parts. And it can also proxy to backends. So effectively, we've got a single server component that can take care of all of the major infrastructure jobs for a web application. And that's essentially the vision for Unit, is that we're trying to build this one server component to deliver all the things that you need to deliver a web application with a single configuration in a nice, lightweight, high performance runtime. And we went into this vision with some explicit design goals. And that was, as I said, we haven't copied any code from NGINX, but we've copied a lot of the DNA. And a few things that went into that is that we didn't want to have a bespoke configuration syntax. So the NGINX configuration syntax, if you've ever used it, looks fairly conventional, but it is a unique thing. And if you ever want to try and sort of programmatically configure it, there's quite a lot of heavy lifting to do. So we didn't want to invent a new configuration language. We wanted to keep that really elegant reconfiguration experience where there's no impact to clients or no impact to in-flight requests when a configuration changes. We want to go one step further and have configuration changes happen immediately and in situ of the running process. So we don't even need to create another copy of the process to handle that. And that basically gives us a real-time configuration API. And thirdly, we wanted to have request routing that was loosely coupled to everything else. So as I'll show, we have a number of top-level objects, and it allows us to have a very powerful and flexible request router built in to Unit that allows us to solve a whole bunch of problems that are sort of ever present with modern web frameworks. And so, as I said, the Unit's architecture is evolved from NGINX. It's a little bit different. We've got this familiar asynchronous event loop in the router process in the middle of the diagram here. The main difference is that that's now multi-threaded. And we're multi-threaded because application runtimes are multi-threaded, and so we need to have a very thread-safe and thread-aware central runtime component, and it's this multi-threading that allows us to update the configuration on the fly. So we've got also the main process that starts and stops things, and the controller process, which is all about the configuration and accepting configuration changes and then applying those changes to the root process. But there's one more thing in the Unit architecture, and that is that it also has application processes, because Unit is an application runtime. It can natively run, as per this diagram, Python and Java applications all at the same time. And so it also controls the process management of the application runtime itself. And so there's everything you need to deliver static content dynamic content, both locally through application code and proxy into backends, all in one. It's a daemon. And what's more, Unit can run applications in 7 different languages today. We have another couple in development. Of course, we care about Java here today, but that also means we can run things in Spring Boot and other Java web frameworks. All of this stuff is documented on our website. But focusing on Java, Unit supports Java. That means it can run Java applications. We support the Java Servlet 3.1 API, just JSR 340 if you know the spec, on any Linux or Unix-based runtime platform or a Docker container. So I'll show you, run it on a MacBook or a Linux host. We have Java runtime, or we support Java versions 8 through 19. Exactly which ones we support depending on the underlying platform. And you can configure Unit to run jar files, WAR files, or JSP files natively. And just to illustrate that, the documentation I pulled a screenshot from this morning shows some of the options that we have available when configuring Java applications, such as class paths and setting the JVM runtime options on the fly. So I'll drop into a demo in just a sec, but just want to touch on a few of the challenges that we see with people building and running web applications. Firstly, actually, this is common across pretty much all modern web frameworks, is that serving static files is usually non-trivial and can be a bit cumbersome. And that's, of course, related to how the request routing works, either needing to sort of pre-register sort of URI paths or prefixes so that the application runtime knows whether to handle each request as a static resource or not. And the runtimes tend not to be super efficient as web servers. They're designed to be application servers, and serving static files tends to be a bit of an afterthought in their own implementation, and kind of slow and cumbersome to configure. The same is true for TLS management. So increasingly, we're seeing a need for end-to-end TLS on web applications. That's right through to the runtime. Usually, we'll see people terminating TLS a reverse proxy, either co-located on the same server as the code, or maybe just slightly downstream of that at a reverse proxy or a load balancer. But either way, certainly putting TLS certificates in application code, if you do have strong TLS requirements, is a pretty horrible thing to try and do. And of course, they expire. And finally, when building full web applications in Docker, you tend to quite commonly have more than one service that needs to be running, and that comes at that's an anti-pattern as far as Docker is concerned, and something that end up solving in various different ugly ways. Craig, good spot on Perl. We don't have a lot of Perl users, but it was a light lift from one of the existing language implementations that we had. And for what it's worth, I have built a demo application that runs all 7 languages. .NET, yes. .NET is a work in progress. So we're looking to support .NET Core in not too distant future. So we get lots of asks for that. Thanks for the commentary. Okay, this sounds like a good time for me to show you what I've been talking about for the last 20 minutes or so. And if you are familiar with NGINX, one of the first things you'll notice with unit configuration is that it looks completely different. So let me switch to a terminal. Hopefully that font size is big enough, but tell me if it needs to be bigger. And we're going to run up a unit server and make it do a couple of things. We'll make it be a web server just to make sure that everything is working, and then I'll make it run a simple Java Spring Boot application. So first thing I'm going to do is start the unit daemon. Thanks for confirming. Font size is okay. So unit daemon. Bizarrely, I'm going to say don't be a daemon just so I can see all of the output in the console. And I'm going to send all my logging to the console as well. And usually we have the control API on a Unix socket, but that is a little bit cumbersome to use in a demo. So I'm going to have it listed on port 8080. And I'll send all that to the background. So there we go. Great. So unit started up. So I'm seeing all of its logs. Now you'll notice I've got a Java 11 module loaded, and I've got all the other, or some of the other language modules all loaded as well. These are not necessary, and each of these modules is linked to runtime. So you only need to install the language that you need. But of course, this is my laptop, so I've got everything here. Got OpenSSL linked. So here we are. That's unit is now running. So we've got an HTTP API for configuring unit. I'm going to start off using curl, and then I'll switch to a command line tool to make it a little bit easier. But just because, as you can see, I'm typing impaired. So if I talk to port 8080/config, there's no config, right? So there's this is a clean install. I wiped the config before I started this demo. There's absolutely nothing there. So let's make unit do something useful. And I've got a configuration. I'm going to delete it, and I'm going to start a new one. So the configuration for unit is in JSON format, and there are 3 principal objects. Firstly, listeners. And I'm going to start off listening on port 9000 on all my interfaces. Yeah. And what I want unit to do when I listen on that is to pass to the router, so the routes object. So that's all I need to create a listener, but of course passing to routes is not going to do anything because I actually need some. John, to answer your question about OpenAPI, we do have an OpenAPI spec in progress. It's not published yet, but we do a few things with JSON which are sort of superset the OAS standard, so it's a little bit cumbersome for us to write it. But working on that and working on a Visual Studio tool as well. But there's really not that much to it. So I need routes. Unlike listeners, it's an array. We can have multiple. We can have multiple in either, but an array because JSON arrays are ordered. So my routes are going to be hit in this specific order that I mentioned, and I'm just going to have potentially a default route here. Some of you may have noticed I'm switching between routes and routes because I've been polluted by my American colleagues. Don't forgive me. And what I want to happen if I hit the default route is to share files. So I'm going to type this, okay, demo. And I've got an HTML directory with 1 file in it, and I'll pass in the URI variable to that. Now, that's everything I need. So let me just cat that JSON. I'm just going to pipe it through JQ just to make sure it's good JSON. Good. And now I'm going to send it to the control API. So I'm going to use the put method, and I'm going to take the data from standard input, and I'm going to send it for 8080/config. And it's reconfigured. Fantastic. So now I should be able to use let's use curl again. This time we'll go to port 9000 because that's what I told unit to listen on, port 9000, and then we get a hello world. And there's my HTML directory with the same file. So it's a web server. So far, so boring. Let's make it do something more interesting. So I'm going to have it run a Java application. I've got a simple Spring Boot application in this called add. It's a microservice. So let's see, source, main, Java. There it is. Okay, so it's my add application. It's the probably the most simple Spring Boot application you've seen. It's the first one that I've written, so forgive me for having absolutely zero exception handling and not using all of the right objects. But it kind of works if I send it exactly the right data. So let me just walk you through what it is. So as I said, it's basically it's a JSON REST microservice. It registers the /add URI as a post mapping. So if I post JSON data to /add, then I will iterate over the operands array here, and for each operand I will add it in sequence to a variable that starts at 0. So this is a ridiculous JSON REST microservice that adds numbers together and gives you the result, but it'll do for a demo. And then at the end, I either, depending if I've got a decimal or not, will send back a floating point or an integer. So that's my application. There's only, apart from it being a basic Spring Boot, this is the only other dependency, which is very common for Spring Boot apps. That is built into into a WAR file, and I'm going to need to reference this because that's what's going to run it. So I've got no other moving parts here, no Tomcat, nothing else. I know I could run this in the built-in Tomcat server, but we're looking here about what I might actually run in production. So let me update my configuration. I need to do two things. I need to add a route to say, well, /add now goes to my Java application, and then define the Java application itself. So let me add that route first of all. So that's going to be here. And this time I need to match because that second route is a catch-all. The nice thing about Unit is I can match on anything. So I can match on URI, cookies, query parameters, HTTP methods. Any part of the HTTP metadata is as good as any other part of the HTTP metadata. There's no, we're not predicated on being a web server and doing sort of URI and host-based routing, such as NGINX. Of course, this is a nice simple demo, so I'm just going to match on /add. And that happens. I want my action. This time, I'm not going to share, I'm actually going to run an application. So I'm going to pass it to applications object /add. And that I better define it. So let's do that. So I can have multiple applications, multiple languages. But in this case, I've got one called add, and it's going to be of type Java. The other thing I need is I'm going to paste this in. So just typing this much is going to give me a bug. So I just defined the web app. It might be a WAR file, might be a jar file, might be a JSP. If I'm doing something just scripty, and I'm just targeting the WAR file that I showed you that I built earlier. So if we're listing on port 9000, all of that goes to routes. If I match add, I'm going to go to applications add, which is this, and anything else is going to serve a static file or try. So that should be all I need. Let's save that. Just test the JSON again. Good. And this time I'm going to use Unit C, a simple command line tool. We just check the config I already have. Yep. And now let's send in conf.json. Stuff happened. So I started an add prototype, which helps Unit fork new processes much quicker. And then the first of my Java applications. So I could have configured how many processes I want to start, how many to keep idle. I could have configured extra class path info for my Java app to put in other dependencies. I could have configured a bunch of other sort of JVM runtimes like log files and things. But because I asked for the log to go to standard error, I'm getting all of this stuff to my console. And then finally, the unit told me that reconfiguration is now done. So I can now continue to, let's use the HTTP client. Oops, port 9000 gives me a hello world HTML page. Now let's go to /add, and that's not allowed because I registered it as a post. So let's send it that array of operands. So the idea here is that I want to do something like this. JSON array, like so. All right, so I'm going to use HTTP again for this. Let me bring it to the top. It's got a nice, useful JSON creator. All right, so no, what to do -b. So verbose output again to /add. It will post by default if I send it this JSON constructor. There, so I sent this as a post. We got some logs, and then we got a result back from the unit server to say the 1, 2, and 3 is 6. So all I've got running is unit and its processes, including my one unit application that is managing for me. No other web servers or proxies or anything else. So it's a very simple, lightweight way to run Java applications in a very conventional way. Spring Boot works. We've got a how-to guide for that, but any other Java applications work equally well.
Yeah. Question.
Yes, please.
Are there plans to support Unit as an embedded web server within Spring Boot?
Not as yet, but it's an interesting question as I've been going through the process of building out this demo and experiencing the built-in Tomcat in the in that dev cycle. I've asked myself the same question. Essentially, there's no reason why not. We actually built our language module that supports Java by taking a lot from Tomcat anyway. Certainly the way that essentially Unit's job is to carry the HTTP context that we've received in our web server and then send that across to the application runtime using the right schema essentially to hand it off and then receive the response back. So there's no reason why we couldn't. I'd be interested to dig in. Maybe we can do that offline as to.
I mean, just really briefly, in terms of adoption, I can tell you as a Java developer, the last time I worried about Apache was when I had to hook up Apache to forward everything to Tomcat that was a JSP. When I started using Spring Boot and I had an embedded Tomcat, like I didn't care about the web server anymore until it became an issue where if I were just serving static content, then I would use NGINX. So I mean, being able to embed it in something like Spring Boot would make it much easier for typical Java developer to start using this and then be able to realize any other benefits.
That's great feedback. Thank you, John. We're continuing to look for the pain points that currently exist, and they're subtly different across the different web frameworks and languages. So yeah, to you and to anyone else on the Zoom, if there's I'd love to hear kind of what's painful right now with the way things currently are. Would love to certainly feed that back to the team. So I'll show one more thing before I jump out of demo mode, and that's I'll use the CLI tool again to examine the config. And so now we've got the listeners object, the routes object, and the applications object. Now I've been changing this all in one go by sending that JSON file to the control API, but I can change individual things. And I can do that quite quickly on the command line. So the config API is hierarchical. So I can go to roots, and that's an array. And if it's an array, I can enumerate. So I can go to root 0. And then I can keep going to match and add, and I can see, oops, sorry, just match, which is, it says, tell me which URI I'm matching on. I can then start changing these things one at a time, or I could go to where I'm sharing, or even the listeners. I'm just going to change it, but I realize that I registered /add in my Java app, so if I change it to something else, it's going to break. But I can send new controls. In fact, I did kind of cheat because I have one certificate loaded for this host name, and if I actually want to change my listener to switch from plain text to TLS, I could do something like this. Basically, specify a different port that goes to applications add or goes to the roots. Actually, let's do that. Make this the last thing I do. Pass to roots. And I can pass that to just listeners. And that's now done. So if I go back and send my HTTP request again, that doesn't work. But if I send it to HTTPS port 9443, I now have a TLS enabled Spring Boot app, and I can rotate that certificate using the unit API as I was just using. So that's another great benefit of Unit, is I can actually deliver end-to-end TLS right to the runtime when there's the only part of plain text in that whole chain is across shared memory between the router and the Java runtime on Unit host. So it's as close as you can get to true end-to-end TLS. Okay, so show a quick use case for Spring Boot app. I want to just touch on existing. We talked about this at our conference last year with a customer in the US that migrated some very old Java apps on Java 8 onto Unit, and really enjoyed the configuration experience there, and how they could essentially modernize their monoliths by moving them to Unit. It allowed them to do a lot more, have a lot of flexibility on the routing without touching any code, and as I said, to add TLS to these applications without any other moving parts. So we do have people using Java in production in mission critical applications. And so getting back and sort of moving to wrap up, the vision for Unit is to basically have the developer control part of the application stack, cover the code and Unit. So one of the mantras that I like is deploy code, not containers, and it allows you to focus on just the application code, send it into Unit, and it's going to run. And actually, it's going to run exactly the same way, even if you're using, or if you're building whole applications with multiple different languages. I showed some of these configuration objects as I went through. Actually, I showed most of them, listeners, routes, applications. I didn't show upstreams. We can also do reverse proxying for maybe URIs that have to be handled somewhere else. And we've actually just, in the last release, introduced the ability to write configuration in JavaScript. So that's an embedded server-side interpreter for JavaScript in the configuration language. So you can do some quite complex routing, for example, with that kind of thing. The key point here is that really that the Unit configuration covers everything from layer 4 on that listen port all the way up to the runtime, all in one place. And it's a lot easier to introspect an application in production when you know that this one unit daemon is taking care of all of those. So for use cases and why you should use Unit, I've touched on a couple. Modernizing monoliths is a really interesting one. Actually, it's a great place to start for a microservices journey. If you can move a monolith to run on Unit, you're in a great place to start carving out pieces of functionality to other applications that Unit can run, and you can really leverage the Unit router to know which bits should be run by the monolith and which bits are now run by a new microservice. And that microservice might be somewhere else, or it might be co-located with the same monolith. And actually that simplifies things even further. It's maybe not the end goal, but it does allow for introducing microservices, choosing the appropriate language for each one, and being able to update them as often as is necessary. All of the key tenets of microservices. You can do all of that without having to have half a dozen containers. In terms of security, I touched on that encryption end-to-end piece. One thing I didn't mention is that Unit can also run each of the applications in its own C group, fully isolated. So I've got a diagram for that. So what that means is Unit can run C groups, it can cheroot them with a root file system, and it can run each application as a different run user. So applications are very well isolated from not only the host, but from each other if Unit's running multiple applications. And it means that you can really get down to a very simple, secure runtime environment where the TLS runs end-to-end, and it's the router at Unit which is doing the final piece of decryption and handing off the HTTP context over shared memory, the application runtime itself. And that's it. So I hope this is interesting or intriguing. We've got a website. It's a fully open source project on the NGINX GitHub. And we have a community Slack as well as active issues. So would love to know what you think. And if there's anything interesting, either come back to me now with those pain points that you have in with Java or web apps today, or anything that you think is missing or doesn't make sense from my explanation. Craig, thanks for the question. Currently, we offer tech support for customers of NGINX Plus. We don't have mainstream tech support for NGINX Unit. Let me know if that's something that's interesting. We're really still fairly early bootstrapping this this is run as an open source project, somewhat in isolation to the rest of the business, but funded by a fund.
I'm just giving it a few seconds in case anybody has any burning questions they want to ask you before I bring us to a warm close. Thank you so much for coming to speak to us, Liam. That was really interesting to hear about. Love it. Does anybody have any burning questions? I'm going to take that as a no for now. But like Liam says, if you do think of anything you want to chat to him about, please do get in touch, and he'll obviously be able to talk to you. So thank you all for joining us for today's session. Thank you so much, Liam, for coming and sharing some of what you know and showing us all of this. It has been really interesting and really great to have you. So thank you. And I hope you all have a great rest of your week, and we'll see you soon at another LJC event. Thank you so much for joining us. Have a great day.
Thanks all.
Thanks. Bye.